Friends, I, Digvijay Charan, welcome all of you in this episode. Today I will discuss about lever rule. Lever rule is a method to calculate the weight fraction in a binary system. In a binary system, there are two phases involved. That's why it is called binary system. Out of two phases, the weight fraction of each phase can be calculated. I will tell you how. Now this is iron carbon diagram which I explained you earlier also. In the diagram, I will give you one example. 0.2% carbon steel composition if I select. Now here is the imaginary line of 0.2% carbon steel. And I intend to know the ferrite and cementite percentage. Here is line of ferrite, here is line of cementite. And here is the imaginary line of 0.2% carbon steel. To know the ferrite fraction, I will consider opposite branch touching cementite. It means 6.67 minus 0.2 is the branch touching cementite but opposite to ferrite divided by total distance 6.67 minus 0.008. Now you can see here 0.2% carbon steel ferrite is equal to the branch opposite to ferrite but touching cementite, that is 6.67 minus 0.2 divided by 6.67 minus 0.008 into 100 is the percentage. What about cementite percentage? If I come to the diagram, in 0.2% carbon steel, if I intend to know the cementite percentage, I will consider branch opposite to cementite and touching ferrite. So 0.2 minus 0.008 is the branch opposite to cementite but touching ferrite. So 0.2 minus 0.008 divided by total distance 6.67 minus 0.008. You see here, cementite percentage is equal to 0.2 minus 0.008, the branch opposite to cementite but touching ferrite, divided by total distance into 100 is the percentage. See the second example, 5% cast iron. Now come to the diagram. I intend to know again ferrite and cementite percentage. Now come to 5% cast iron, the line here, because this is 4.3%, so 5% will be here. This is 5% cast iron. At 5% cast iron composition, if I intend to know ferrite and cementite fraction, proportion, how I can calculate? For 5% cast iron, to know the ferrite which is here, I will take opposite branch, that is 6.67 minus 5 divided by total distance 6.67 minus 0.008. You see here, ferrite percentage is equal to 6.67 minus 5, the branch opposite to ferrite but touching cementite. And there is a imaginary line at 5. So the branch opposite to ferrite is 6.67 minus 5 divided by total distance 6.67 minus 0.008 into 100 is the percentage. If I intend to know cementite percentage, you come here in the diagram. 5% carbon cast iron. If I intend to know cementite fraction, I will take branch opposite to cementite but touching ferrite. So 5 minus 0.008 divided by total distance 6.67 minus 0.008. See here. Cementite percentage is equal to 5 minus 0.008 divided by 6.67 minus 0.008. But this is a branch opposite to cementite and touching ferrite divided by total distance into 100 is a percentage. 0.2% carbon is steel. Here is ferrite, here is perlite. And there is imaginary line of 0.2% carbon is steel. For ferrite, I will take a branch opposite to ferrite touching perlite. So 0.8 minus 0.2 is a branch opposite to ferrite touching perlite divided by total distance 0.8 minus 0.008. You see here. Ferrite percentage is 0.8 minus 0.2 is a branch opposite to ferrite and touching perlite divided by total distance 0.8 minus 0.008 into 100 is a percentage. Now perlite percentage, branch opposite to perlite but touching ferrite, that is 0.2 minus 0.008 divided by total distance into 100 is perlite. See here. In 0.2% carbon steel, if I intend to know perlite percentage, then 0.2 minus 0.008 divided by total distance. 0.2 minus 0.008 divided by total distance is the percentage. Come fourth example. 1.2% carbon steel. If I intend to know perlite and cementite percentage, earlier I had done ferrite and cementite percentage. Now I will calculate perlite and cementite percentage. So there will be imaginary line at 1.2% carbon steel. Perlite, for perlite, I will take the branch opposite to perlite touching cementite. So 6.67 minus 1.2 divided by total distance 6.67 minus 0.8 into 100 is the percentage. Now cementite percentage is equal to branch opposite to cementite touching perlite. So 1.2 minus 0.8 is the branch opposite to cementite but touching perlite divided by total distance into 100 is the percentage. In any binary system where there are two phases, you can draw a imaginary line at the given composition and you can calculate weight fraction of each phase by applying Weber rule. For first phase, take a branch opposite to first phase touching the second phase. For second phase, take a branch opposite to first phase divided by total distance. Now 3% carbon in cast iron. 3% carbon in cast iron. I want to know lateborite and ferrite percentage, lateborite and ferrite. So 3% carbon in cast iron. So here is the 3% carbon. If I want to know ferrite and lateborite percentage, here is ferrite, here is lateborite. For lateborite, I will take arm opposite to lateborite. So 3 minus 0.008 divided by total distance 4.3. This is 4.3. 4.3 minus 0.008. See, 3% carbon in cast iron. Lateborite is 3 minus 0.008. Branch opposite to lateborite and touching ferrite divided by total distance 4.3 minus 0.008 into 100 is the percentage. Now ferrite, branch opposite to ferrite touching lateborite. So 4.3 minus 3 is the branch opposite to ferrite touching lateborite. You see, for 3% carbon for ferrite, branch opposite to ferrite but touching lateborite. So 4.3 minus 3 divided by total distance. 4.3 minus 3 divided by 4.3 minus 0.008 into 100. This is the percentage. Another example, 5% carbon in cast iron. If I intend to know ladeborite and cementite percentage, not ferrite and cementite, I intend to know ladeborite and cementite in 5% carbon in cast iron. Now come here, 5% carbon in cast iron. Now ladeborite and cementite fraction. For ladeborite, I will take the arm opposite to ladeborite touching cementite. So 6.67 minus 5, that is branch opposite to ladeborite and touching cementite. So 6.67 minus 5 divided by total distance 6.67 minus 4.3. See here, ladeborite and cementite. For ladeborite, 6.67 minus 5. That is branch opposite to ladeborite touching cementite divided by total distance. Cementite percentage, branch opposite to cementite touching ladeborite 5 minus 4.3 divided by total distance. Because at 4.3 we have ladeborite, at 6.67 we have cementite. For cementite percentage, 5 minus 4.3, that is branch opposite to cementite touching ladeborite. So 5 minus 4.3 divided by total distance into 100 is a percentage. So these are a few examples where I have shown you how to apply in a binary system the lever rule. In a binary system, when you fix both the ends, ferrite perlite or ferrite cementite or perlite cementite, ladeborite cementite, any two end you fix. In between these two ends, at any point, you can calculate the weight fraction of any of the two phases, either of the two phases. So anywhere you take a point and fix two ends, you can calculate in a binary system the weight percentage of any one phase. This is called lever rule applied in any binary system. Here it has been applied in iron-carbon diagram. Friends, in next video I will discuss about the macrostructure of carbon steel and cast iron, and I will also discuss about the types of carbon steel and cast iron used in industry. Friends, if you like this video, please subscribe the channel, share the video and like the video. Thanks.